Welcome everyone. So today let's take another misconception. This is a question which I got from one of my students in my WhatsApp number from Surya Prakash. So the question is this is based on this misconception whose components to take. So generally even in my childhood I used to have this doubt. A teacher कब किसी का component ले लेता है पता नहीं चलता. Like sometimes teacher takes component of V and he equates that V cos theta with U. Sometimes the teacher takes component of U and then equates it with V. U cos theta equal to V. तो V का कंपोनेंट लेके V cos theta equal to U लिखे या U का कंपोनेंट लेके U cos theta equal to V लिखे कब किसका कंपोनेंट ले ले right. So this is one of the important questions which is generally there in the minds of students, and while answering exams in neet they face this challenge and they make the mistake. So let's see when to take components of which velocity, right? So here is a question. So here this is a block of mass capital M. It is connected to two identical blocks of mass small m through two strings passing over two pulleys. And here these ropes they are making angle theta with the vertical. These two masses, the identical masses small m, they are going down with speed u meter per second, and because of that the capital M has to move up with some velocity. The question is find out that velocity v with which this block capital M is going upwards. Hope you understood the question. So these two blocks are going down with speed u meter per second. Find out the velocity of this capital block M with which it has to move up. Here the question is little different. Here also you see you have a pulley and here there is a fixed rod. This angle is theta. Now here this rope is connected to two blocks. Here small m and here capital M. This capital M is connected first to a ring and then the ring is connected to the rope. So here also what is happening? This small m it's moving down with speed u meter per second, because of which this rope moves down. So this rope moves along the incline, along the rod, and because this rope moves like this, so this capital M has to move up. That means if you imagine after some time, let's say the ring is here, so the capital M is somewhere here. Hope it's fine. Similarly here also after some time the rope becomes like this. So the capital M comes here. Is it fine? So let's find out. So here also we have to find out the velocity of capital M only. The question is in both the cases to find the velocity of the capital M. So let's see whose component has to be taken. Okay. So the simple idea behind solving all these questions is you first try to see what is the actual direction of movement of the point. Here you see this point is moving up, isn't it? This point is moving up. The actual direction of motion of this point is vertical upward, not sideways. But it has an effect. If this point has to move up, if this block has to move up, that's the actual direction of motion. Then the rope becomes like this. The rope gets shortened. Because the rope gets shortened here, therefore the rope here it becomes elongated. So here this block goes down. So here you see the actual direction of motion of the body is vertical upward, and it has an effect in this direction, isn't it? Therefore here we have to take the component of v, right? So if it is moving up with velocity v, then how much effect it has in this direction? You take the component of v in this direction, it is v cos theta, right? Therefore here we have to take the component of v. It is v cos theta. So if it has to move in upward direction with v, then along this direction the rope has to get shortened with v cos theta. And if this rope has to get shortened with v cos theta, then this direction the rope has to get elongated with v cos theta. And that's u. It's given that it is getting elongated with u. So v cos theta equal to u. So v in this case equal to u by cos theta. Hope it's clear. Acha, now look at this question. Here you see what is the actual direction of motion of the ring. The actual direction of motion of the ring is in this direction, and its effect is the block has to get lifted up. So here the ring is not moving vertically upward. The ring is moving in this direction, but its effect is that the block has to move like this. So the ring has to move like this. Acha, with what velocity the ring has to move like this? Because this rope is going downwards with velocity u meter per second, so this rope has to get shortened. This side it is getting elongated, so this side it has to get shortened. So if here this side is moving with u meter per second, so this ring is moving in this direction with u meter per second. So the actual velocity of the ring is not vertical, it is along this direction with u, but it has effect in this direction. So I have to take the component of the actual velocity. The actual velocity is u. Now its component in this direction will be u cos theta. So the component of actual velocity is u cos theta in vertical direction, u cos theta, and because of that effect, it is getting lifted up. So it is equal to v. So now it comes out to be v equal to u cos theta. So sometimes v can be u by cos theta, and sometimes v can be u into cos theta. Here v equal to u into cos theta. Here v equal to u by cos theta. Right? Hope you have understood it. Whose component has to be taken? So simple. It's simple. Try to find out what is the actual velocity, and then take its component in that direction in which we are finding its effect. As simple as that. Here actual velocity is upward, so it is v. Its effect is in this direction, so its effect v cos theta, that's equal to u. Here actual velocity is in this direction, that's u. Take its component u cos theta, so its effect is in this direction, that is u cos theta, so u cos theta equal to v. Hope it's clear. So hope to get more questions like this from all of you students. If you like this video, then please like our channel, subscribe it, and share this among your friends. If you have such questions, you can always ask me either by commenting in the below section or by sending me the question in WhatsApp. Thank you.